So we're being asked about electron configuration in this question. We've been asked to give the full electron configuration of the aluminium atom. So the first thing that you need to do is go to your periodic table. So you want to find your periodic table and look up aluminium. Okay, so find your periodic table, look up aluminium. So here we go, we've got aluminium in our periodic table, just in group 3. And we can see that from the periodic table that aluminium has 13 protons, and therefore an aluminium atom would have 13 electrons. So we go back to our question and we're going to have a look at aluminium, which is number 13 in the periodic table. Therefore, if it's an atom, if it has 13 protons, it has 13 electrons. And then we're going to use our order of filling. So we fill the first shell into the S subshell with 2 electrons, and then we go into the second shell, the S subshell, and we can place 2 electrons. We've still got enough electrons, so we keep on going. The second shell, the P subshell, which can hold up to 6, that would take us to 10, and we've got 13, so we keep going. And then we go into the third shell, the S subshell, we can put 2, that makes 12, and then the third shell, the P subshell, we've got 1 electron, and there's our full electron configuration of aluminium. Now, does that make sense for its position in the periodic table? So if we just go back and have another look at our periodic table, we've got 1s1, 1s2, 2s1 and 2, 2p1 to 6, 3s1 and 2, 3p1. So this does make sense. It's in the third shell, third period. It's in the P subshell, and the P subshell refers to this part of the periodic table here, and it's the first one along, so 3p1. We're then asked for chromium 3+. Now we would follow a similar pathway. We would look it up in the periodic table and find out that chromium is element number 24 in the periodic table. So chromium has 24 protons, but this is a chromium 3+ ion. So we're only wanting 21 electrons. Now you need to be careful with transition metals, because although it's tempting to just write the electron configuration of 21 electrons, and that would be the electron configuration of scandium, that may not give us the right answer, because with transition metals we fill the 4s subshell first, but we also empty the 4s subshell first. So what I would do is, in pencil, something that you can rub out, I would do the full electron configuration of a chromium atom with 24 electrons and then remove the last 3. So I'm going to do that. I'm going to do 24 electrons. So I know that I've got to get to the end of 3s and 3p. That's argon's electron configuration. Now I would fill 4s first, but what I like to do is leave a gap, because I'm going to keep all the 3's together, but I would fill 4s first with 2 electrons. Now that's taken me up to 20 electrons, and then I would go back and I would fill the 3d with the remaining, in this case 4 if I was doing chromium. Now I'm doing chromium 3+, so now what I want to do is I want to take my rubber and I want to rub out the last 3, so I'm going to remove those 2, and I'm going to take this number 4 down and change it to a 3. Now if I'd have done the electron configuration of scandium with 21 electrons, I wouldn't have got the exact same answer here, because I would have got 4s2 and 3d1, so it is important to be very careful with transition metals. Now we're being asked to deduce the formula of an ion, so it's going to have a charge, so we need to make sure we have a charge. It has a charge of 2+, so it's a positive ion, and it has the same electron configuration as krypton. So I'm going to just look up krypton in my periodic table again. So if you go find krypton, you can find that it's number 36. Okay, so krypton has 36 protons and 36 electrons. Now something that has a charge of 2+ with the same electron configuration as krypton would need to have 36 electrons to have the same electron configuration as krypton, but 2 more protons, so 38 protons. So then I'm going to go to my periodic table and find the element number 38, which is strontium, because I need 2 more protons to give me that 2+ charge. And then I can put in the 2+ charge because it's the formula of the ion. I must remember the charge. The last one on this page, it says deduce the formula of a compound that contains 2+ ions with the configuration of argon and 3- ions with the same configuration. So let's look up argon, element number 18. So that would have 18 protons and 18 electrons. Now both of my 2 ions are going to have 18 electrons, but to have 2+ charge I need 20 protons. So I'm going to look up element number 20. Calcium, I'm going to make it 2+. To have a 3- charge, I would need to have 3 less protons, so 15 protons. So I'm going to go and look up element number 15, phosphorus, and give it a 3- charge. And now I need to put those 2 together in order to form a formula of a compound. So 2+ and 3-, common multiple is 6. How many calcium 2+ to get 6+? Well, you would need 3. And how many phosphide ions to get 6-? You would need 2. So we're going to go calcium 3, P2, calcium phosphide.